Hello, today we are going to look at how we can use the quadratic formula in order to solve quadratic equations. Now remember, we have synonyms here. If you want to solve a quadratic equation in the graph of its related function, you can look for the x-intercepts. Those things are also called the roots, and they're also called the zeros. So in order to use the quadratic formula, you need to start out with a quadratic equation that's written in standard form. So by standard form, I mean it needs to look like ax squared plus bx plus c equals 0. And remember, a stands for your coefficient in front of your x squared, b is your coefficient in front of your x, c is the constant, and you have to have equals 0. If you don't, you need to fix that. Okay, so you have to have an equal 0 in order to figure out what a and b and c are so that you can plug them into the formula. So let's see how this is going to work. Let's start with an example of this quadratic equation. Let's do x squared minus 6x equals negative 3. Okay, so it's a quadratic equation. It's got an x squared in it. So the first thing you want to ask yourself is this in standard form? So, well, it's not, because I don't have an equal 0. So this is bad news that we have a minus 3 here. I don't like that minus 3. Is there a way you can make that minus 3 go away? Well, to get rid of a negative 3, you could add 3. So I'm going to add 3 on both sides of my equation here. I'll squeeze it in right here on the left-hand side of that equals. So we'll have x squared minus 6x plus 3 equals 0. So that is better news because now it is in standard form, so I can identify what a and b and c are. So a is the coefficient in front of your x squared. Well, what's this coefficient? It's not shown, so the understood coefficient there is a 1. So having an x squared and having 1x squared is the same thing. So I'm going to point that out. That's my a value. What's my b value here? B is your coefficient in front of your x. So in this case, it's the negative 6. Now, if you didn't see that negative sign with that 6, you can always add the opposite right here. So you force yourself to see them together, that negative goes with the 6. So your b value is the negative 6 here. And then c is the constant here on the end, so that's a positive 3. So once you know what a and b and c are, you're going to fill them into the quadratic formula. So here we go. X equals negative b. So here's the negative sign that is part of the formula here. Okay, I got to know what b is. What's b? Oh, it's the negative 6. So now this makes you have a double negative here. See that double negative sign? You're allowed to combine those to make a positive, but you have to think about the fact that the formula has a negative. So that's the first one you have written there. And then if the b is negative, then that puts another negative sign. So I'm going to go ahead and add the opposite there. Then there's a plus minus sign. And then there's a square root symbol. Now we need to take the b number and square it. So in other words, I'm taking my negative 6 and squaring it. So negative 6 times negative 6. That will be a 36 minus 4 times, okay, now we need to fill in the a value. A is 1 times, now we need to fill in the c value, and c is 3. All over. And when you draw that fraction line, notice it goes all over. So the entire thing is over the 2a. So be careful when you write that. So 2 times a, 2 times 1 would be 2. So I'll put 2 times 1 so you can see that I thought about filling in that a number. I didn't forget about it. So now we need to do some simplifying here. So we have 6 plus or minus the square root of, if I do this multiplying, I have 4 times 1 times 3, which is 12. So I have 36 minus 12 under my radical. So that's a 24 all over 2, because this 2 times 1 in my denominator, I can simplify to just a 2. Are you with me so far? Hope so. So I would like to simplify this radical here, so I'm going to think about, does 24 have any factors that are square rootable, that are perfect squares. So it does, 4 is a perfect square, and I could rewrite this as a 4 times 6. So, and I'll show you the other way too if you like the tree method. So I'm rewriting my 24 as a 4 times 6. If I cover up the 6 part of it, you can square root 4. The square root of 4 is 2. So I can write that as 6 plus or minus 2 radical 6. So this 2 is coming from the 4 getting square rooted right here. The 6 is still stuck inside the radical, and it's all over 2 still. Now let me pause and show you the other way of simplifying that square root. So if you like the tree method, you would take the 24 and start factoring. You could still call it 4 times 6. You could call the 4 2 times 2. Those are prime. You could call the 6 2 times 3. Those are prime. Okay, so I have 2 times 2 times 2 times 3. If there's a double root here, a double factor, you're allowed to square root that. So together, those two make this 2 out front. These are each singleton factors. They don't have a partner, so they are the 6 that you still see inside. So I don't care which way you use, they're both fine. So now if I look at this big fraction, I notice lots of even numbers. Do you see how all of these numbers out front are evens? What that means is I can pull a 2 out. I can use the distributive property in reverse in my numerator here. So let me bring down my x equals again. So if I factor a 2 out, I would have 2 times the quantity, 3 plus or minus. You could put 1 radical 6, or you can just put the radical 6 all over 2. And then these 2's will cancel out. So you have 3 plus or minus the square root of 6 as your answer. X equals 3 plus or minus the square root of 6. Now remember, that's really 2 answers. One answer is 3 plus radical 6, and the other answer is 3 minus radical 6. So I wonder what this would look like if we graphed this on Desmos. Let me link over to that for a second. So I already have it graphed. This red graph that you see here is the function y equals x squared minus 6x plus 3. So that connects to our quadratic equation of x squared minus 6x plus 3 equals 0. I'm replacing the y with the 0 to connect those two. So if you remember, the solutions are also called the roots, are also called the x-intercepts, are also called the zeros because it's where y equals 0. Now here's where Desmos is not as good as doing this using algebra. Desmos gives us these decimals, and it's rounding to 3 decimal places. That's not super accurate. These are irrational answers that we just came up with, but let me show you what they are. Here, let me write them down, the decimals. I know you can't see this, but I'll show you in a minute. 0.551 and 5.449. So 2 solutions because there are 2 x-intercepts here. So let me go back to this screen. Okay, so I penciled them in here. Use pen. So I would remember what they are, but I want to show you. Oh, let's see, you can't see that. Okay, so I'm going to calculate these real quick. If you remember, right here I have 3 plus radical 6 and 3 minus radical 6. So let's see what that comes out to. 3 plus the square root of 6 is 5.449. Hey, look, that matches one solution here. And then if I go 3 minus, oh, can't see that screen, can you? 3 minus the square root of 6. Hey, that matches my first x-intercept of 0.551 approximately. So we like the radical form better. This is more accurate, okay? So we don't want the decimal unless the problem specifies that you want the decimal. We want the radical form of this. So don't give me the decimal unless I ask for it. In higher math, the radical form or fraction form is preferred. So there's one example of this. Let's do another one. So for this example, let's do example 2. Let's do 9x squared plus 1 equals 6x. All right, so look at that equation there. Move this over here so you can remember what the quadratic formula is. We want to identify the a and the b and c from standard form. Is this equation in standard form? No, we do not like this 6x. This is bad news. Oh, I wish that 6x would go away. Well, how can you make it go away? Well, let's get rid of it by taking it away. So I'm going to subtract 6x on both sides, and I'm going to squeeze it right in here in the middle because I know I want it to be in descending order. I want to start with the x squared and then have the x's and then have the constant, so I'm going to put it in there. So we have 9x squared minus 6x plus 1 equals 0. So now I can identify my a is my 9, my b is my negative 6, and my c is my 1. Okay, so that means we can fill these into the quadratic formula. The reason this is good news is because some things we can't solve by factoring, and sometimes we don't want to graph them, and completing the square takes forever. So it's nice to have the formula as a way to get an answer for sure that's accurate, that we can plug numbers in. So that's why we're doing this. So x equals negative b, so I need negative 6. So I don't like the double negative, so I'm going to go ahead and add the opposite right there while I'm thinking of it. Then there's the plus minus sign, the square root of b squared. So negative 36 times, oh, I said the answer, darn it. Negative 6 times negative 6 turns out to a positive 36 for the b squared. Minus 4 times my a is 9 times my c is 1 all over 2 times a. So that would be 2 times 9 in this case. So I've got everything filled in. Now I just need to clean it up and do the math. So x equals 6 plus or minus. Now let's clean up this part under the radical. We're going to talk about that a lot tomorrow, maybe the next day. So let's do the multiplying inside of here before we worry about the subtraction. So 4 times 9 is 36, times 1 is 36. So I have 36 minus 36, which is 0. All over, my denominator would be an 18. Okay, so there we're at. Now, what is the square root of 0? Well, it's just 0. So what I have in my numerator is 6 plus 0 or 6 minus 0. It doesn't matter if you add or subtract 0. You're going to get 6 both ways. So 6 over 18. I mean, you could put the plus or minus 0, but it doesn't change anything if you add 0 versus subtract 0. So this is just 6 over 18. Now, does that fraction reduce? Yeah, a little bit. It reduces by 6's, top and bottom. So that would be 1/3. So let me show you the connected graph of that. So let me pull up Desmos here. So it's not that red one. Now it is this blue graph here. Okay, so remember the solutions are the x-intercepts. So do you see how that x value is a 0.333? That's the decimal approximation for a 1/3. So that matches. We just have one solution, one root, one x-intercept there, because it happens that the vertex is what's sitting right there on the x-axis. So that's why we only got one solution there. Okay, so now for our third example. So example 3. Let's look at this one. Let's look at 4x squared plus 20x plus 35 equals 6. So is that in standard form? Does it have an equal 0? No. We don't like the 6. So let's get rid of that 6. Minus 6 on both sides. So we'll have 4x squared plus 20x plus 29 equals 0. So let's identify, here's my a, it's the 4. Here's my B, it's the 20. Here's my C, it's my 29. So we need to fill those into the formula here. So let me move this down so we can see it. So here's your quadratic formula. So x equals negative b, that's 20, plus or minus the square root of b squared, that would be 400, minus 4ac. So there's my a, and there's my c, all over 2a. There's my a again. So we have to simplify this part under the radical. So 4 times 4 times 29. Let's see what that comes out to. 4 times 4 times 29. That is 464. Okay, so we have x equals negative 20 plus or minus 400 minus 464 all over, that would be 8 in my denominator. So let me keep simplifying here. I have a little subtraction problem to do inside my radical. So 400 minus 464, that would be negative 64. So I have negative 20 plus or minus the square root of negative 64 all over 8. Okay, so we need to square root the negative 64. Well, let's see what happens if I do that. So I am going to square root a negative 64. What's going to happen? Oh, domain error. What in the world? Why did it tell me that? Well, can we square root negative numbers? Well, we have to pretend. Do you remember when we talked about pretending that that negative wasn't there? So this is going to be an imaginary root. So it's negative 20 plus or minus. Let me put that there. Now, if I pretend that negative's not there, you could do the square root of 64 just fine, couldn't you? What's the square root of 64? That would be 8. So this is 8i. 8 imaginary, because you can't really square root negatives without thinking of imaginary numbers. And then let me bring my denominator over, 8. Now, do you see how everything's even here? That means I could simplify this fraction a little bit, because it's all evens. So I want to pull a 4 out of the numerator here. So I could make it 4 times negative 5 plus or minus 2i. So I'm just using the distributive property in reverse here. Double check that I did this right. When you take 4 times negative 5, see how that would give you that negative 20? And then the 4 times 2i would give you that 8i. So that's a form of your numerator over 8. Okay, now let me cover up this part of the fraction for a little bit. You see the 4/8? 4/8 is reducible to 1/2. Okay, so now this 1, I don't need to write a 1 out front because 1 times anything is still anything. So I'm just going to have the negative 5 plus or minus 2i all over my denominator of 2. So these are imaginary solutions. They're not real solutions. I wonder what that would look like on a graph. Let me turn that one off. So I have the related function here. Now remember, solutions, you're looking for what on the graph? X-intercepts. Let's see where it hits. Hey, look at that parabola. Is it hitting your x-axis? No, that's why there aren't any real solutions, because it never happens. It never hits the x-axis. So those are imaginary roots. So that's how you use the quadratic formula to solve quadratic equations. So remember that Jesus loves you, and so do I, so do your math.